Welcome to 6.6, Analyzing Graphs with Quadratic Functions. We're going to analyze and write quadratic functions in vertex form. So first, vertex form is y equals a times the quantity x minus h in quantity squared plus k, where h and k is your vertex. So we're going to analyze this graph. Y equals quantity x plus 2 squared plus 1. So the idea here is it's in vertex form. So our vertex is negative 2, 1. The axis of symmetry is at x equals negative 2. Then we can pick some points on one side of the axis of symmetry, such as negative 1, 2, and 0, 5. And we can graph that part. And we can use symmetry to complete the graph. So next is a concept summary. The idea is the vertex and axis of symmetry is all about h, and hk is our vertex. If we want to translate it up or down, we just change the k. If it's negative, it goes down. If it's positive, it goes up. Horizontal translation, if our h is positive, it goes right. If our h is negative, it goes left. If a is positive, it opens up. If a is negative, it opens down. And if a is greater than 1, it gets narrower. If it's less than 1, it gets wider. So this one, write it in vertex form. So the idea is that x squared plus 8x minus 5 is not a perfect square. So we're going to complete the square by adding 8 divided by 2 squared, which is 16. So we're going to add 16 to both sides, or to the inside. If we add 16 to one side, we have to subtract 16 from the same side. The idea is we would have added 16 to y, which wouldn't have helped us. Okay. So we can simplify. Negative 5 minus 16 is negative 21. We can write x squared plus 8x plus 16 as a perfect square trinomial, which is x plus 4 squared. So our vertex is negative 4, negative 21. The axis of symmetry is negative 4. Since a is 1, the graph opens up and has the same shape as y equals x squared, but it's translated 4 units left and 21 units down. Next one, a is not 1, so it's negative 3x squared plus 6x minus 1. Here is our original equation. We're going to group ax squared plus bx and factor, dividing by an a. So negative 3x squared plus 6x divide by negative 3, and you get x squared minus 2x. Still have the negative 1 outside, and that's fine. Now we're going to complete the square by adding 1 inside the parentheses. Notice that this is overall addition of negative 3 times 1. So we're going to balance this addition by subtracting negative 3 times 1. So we're going to add 3 times 1. Simplify, we write x squared plus 2x plus 1 as perfect square. So we get x minus 1 squared plus 2. So our vertex is 1, 2. That's our h and our k. The axis of symmetry is at x equals 1. Since a is negative 3, it opens downward and is narrower than the graph of y equals x squared. It is also translated 1 unit right and 2 units up. See, now we can graph the function. 2 points on the graph is to the right of x equals 1 are 1.5, 1.25, and 2, negative 1. Then we can use symmetry to finish the graph. Our last example, we're going to write an equation given points. So we write the equation for the parabola whose vertex is at negative 1, 4, passes through the point 2, 1. The vertex of the parabola is negative 1, 4, so that's our h. H is negative 1, k is 4. Since 2, 1 is a point on the graph of the parabola, x equals 2, y equals 1. We're going to substitute these values into vertex form of the equation and solve for a. So x is 2, y is 1, our vertex h is negative 1, k is 4. We're going to then, so after we substitute, we're going to simplify. 2 plus 1 is 3, square root of 9. So it's 9a plus 4. We're going to subtract 4, we get negative 3. Divide by 9, you get negative 1/3. So the equation in vertex form is y equals negative 1/3 x plus 1 squared plus 4. Here's our graph. Our vertex is negative 1, 4. Our axis of symmetry is negative 1. Our A is negative 1/3, so it opens down and is wider. All right, good luck on analyzing graphs.